So Lattice has what are called panel functions. So when you have a multi-panel plot, there's a function that gets called to kind of plot the data in each one of those panels, and that controls what happens in each one of these panels. Lattice package comes with a number of default panel functions, but you can supply your own if you want to customize what happens in each panel. And so basically each panel function receives the x and the y coordinates of the data points in that particular panel. So remember, each panel is going to represent a subset of the data, which is defined by the conditioning variable that you give it. And so each panel function will for every panel, the panel function will get the xy coordinates of the points that are in that plot. And so you can see here I'm generating some random data that are kind of follow a linear model, and I create a factor variable, which is basically just separating out group 1 and group 2. And now I want to plot x and y by group. And so here I've got two panels. In group 1, it looks like a strong linear relationship, and in group 2, it looks like there's no relationship. So here you can see I'm calling a custom panel function via the panel argument, and I give it a function. So the first two arguments are x and y, and then they follow by ... which means any other arguments that may get passed. And so in my custom panel function, the first thing I do is I call the default xy plot panel function just to make the points appear. And then my customization is I add a little horizontal line in each panel, which is the median of the y values in that panel. So now I can see there's a dashed line in each panel right at where the median of the y coordinates is. Another fancier thing I can do is rather than add the median, it might be useful to add a regression line, so you can look at the linear relationship between x and y within each of the panels. So here, again, I pass a custom function, and first thing I do is I call the panel.xy plot function just to kind of make the points appear, make all the axes labels and everything appear. And then I call panel.lm line to add the regression line to the panel. One thing that's worth noting is that you can't use any of the annotation functions from the base plotting system in the Lattice system. So any of the functions that are in the base plotting system can't be used here. And as a general rule, you can't mix functions between different plotting systems. And so you have to use all of the functions that are relevant to the given plotting system. So that's one more quick example of showing kind of a larger data set. This comes from the mouse allergen and asthma cohort study, which is conducted here in Baltimore City, to look at the indoor environment of children with asthma living in Baltimore. And many of these children are allergic to mouse allergen. So this is an observational study in which there was a baseline home visit, and then there was a visit every 3 months for a year, so a total of 5 visits. And so one question you might want to ask is, how does the indoor airborne mouse allergen vary over time and across subjects? So what I want to do is I basically want to make a plot of the airborne indoor mouse allergen for every subject for every visit. So there are 150 subjects in this data set, and they each have 5 visits. So there are going to be 750 data points here. That we want to look at. And so what's a compact way to do that? Well, actually a very easy way to do that is to use XY plot and use a multi-panel lattice plot. And so that's what we've done here. You can take a look at the data, and these are all the subjects in the study, and this is all of their airborne mouse allergen levels. Well, it's the log of their airborne mouse allergen levels. And so you can see the variation within a person. So within each panel, you can see that their allergen levels can go up or down or can vary from visit to visit. You can see the variation across subjects. So you can see that some people have just very high levels and some people just have generally lower levels. So there's kind of that cross-sectional variation in addition to the within-person variation. You can see that a number of people have missing values, so not everyone has 5 values. Some people only have 2 values or 1 value. And so it may be useful to kind of follow up on those subjects to see, okay, well, why does this subject only have 4 values or 3 values? You can see that some subjects have a lot of variation, so they go up and down a lot between visits, and some have almost no variation at all. At every visit is the same level of mouse allergen. And so you may or may not want to follow up on some of these patterns, depending on what exactly you're interested in. And so you can see that with essentially 1 or 2 function calls, you can make a massive plot like this, look at a lot of data without having to go through a lot of code. And so that's part of the power of the Lattice system, which lets you look at a lot of data as long as they're kind of formatted in certain ways. So again, this is the relationship between the visit number and the log airborne mouse allergen levels by subject. right? And so this is a kind of a quick way to kind of summarize all the data in this study. So just to summarize, the lattice plots are constructed with a single function call to one of the core lattice functions like xy plot. Things like one of the nice things about lattice plots is that things like margins and spacings and labels are automatically handled, and so you don't have to set them all the time using like you did in the base plotting system where you had the margin option and the kind of spacings and the M text and the outer margin, and so you don't have to worry about that very much in lattice plots. The lattice system is really ideal when you have data sets that you can look at by conditioning on certain variables. So basically, you want to look at a relationship, but you want to look at it within levels of another variable. So you want to look at kind of the same kind of plot, but under many different conditions. And you can use the customized panel functions to modify exactly what goes on in each of the plot panels. And so that gives you a lot of power to kind of customize the look of these panel plots. And so I find the lattice system very useful for looking at kind of a lot of data in a very quick way. And so I encourage you to try to look at it and look at some of the other functions like BW plot, box plots, and scatter plot matrices to see how they work for you.